Okay, great. Thank you. So today I'm going to talk about how you can use GraphQL as a data layer for your UI. And there's some TypeScript in there, but it's not the main focus because I don't have enough time for live coding. And I think most of the pros of TypeScript are being shown when you do live coding. So I'll explain how TypeScript can help with this, but the main idea is about how you can use GraphQL as a data layer for your UI. So who's this talk actually for? So the idea of having a data layer came out of a frustration of mine when I work with backend teams or when I work with APIs in general. So suppose this is your situation, right? So you have a front-end team, maybe you're part of it, maybe you aren't, and you have a backend team. So who's doing front-end here? So do we also have backenders? Just a few, so I can, sorry, I can make jokes about you or tell terrible. So suppose this is a situation, right? You have a front-end team, you have a back-end team. It's probably not a little situation, like you press the screen and your back-enders are doing exactly the job you want them to do. So suppose you're adding a new feature to your application. So a new feature is added, maybe it's a button, maybe it's a new wish list space for e-commerce. So this new feature is added and typically both teams start updating the code, right? So probably there will be a new endpoint if you're using REST, or there will be additions to an existing endpoint, and then on the front end you need to make the feature work. So basically both teams have to put in the work, and both teams they can collaborate, they can communicate, and they can actually bring the feature to life together. But suppose you don't have an active backend team. I see a lot of products that are built upon an existing backend, and there aren't any backenders to help you make new additions to it. Or maybe the only new additions are changing some fields or some transformations. So a lot of front-end teams are working without an actual backend team. And sometimes you even have one backend for multiple UIs, which is something that really frustrates me as well. So suppose you're working on front-end team A feature get added for front-end team B, and suddenly there are new fields in your endpoints. That's something that can be really frustrating because you're probably not looking for to fetch those information in your application. And also a lot of frustration for me if common backenders are saying, can't you just handle this on the front end? I don't know, probably most of your front enders, how many times did your backenders say, can't you just handle this on the front end? I heard those things mostly every day. So backenders are sometimes a bit neglected to help you solving things on the backend, so you end up changing stuff on the front end, which basically leads to a lot of complicated front ends. As Chris already told, single page applications, you have to handle a lot of stuff. And some of the things you have to handle are those. It's like state management, it's API composition. So if you're using Angular, you're probably using RxJS and you're merging observables together because you need to find a way to get information from multiple endpoints at once. And for React, you have things like React Saga. So those are things you're doing on the front end because probably your backend isn't serving you the correct information at once. And on that similar side, I also do a lot of data normalizations on the front end. And this especially happens if you're using endpoints that have already been created before your UI was created. Or maybe you're using endpoints that aren't transforming in the same way that your UI is transforming. So these are all things you're doing on the front end. And then of course you've got things like caching and authentications, but they are a bit more complex. Especially caching can be really complex on the front end, because you're not really sure what client someone is using, or if people are using the same machine at once. And also authentication, which I'm probably going to leave out of scope, because hopefully your API has some authentication form set up, so you can just send away tokens and then probably you should be fine. So how to solve this? So to solve this, one of my approaches is using a data layer. There are typically always more ways to solve this. But let me tell a little bit about myself first, to give you some context. So my name is Roy. Most of my time I spent working for the City of Amsterdam. We're actually working with a team of like 20 developers to make applications to make the city a better place to work for, but also to make the city a better place to live for, or if you're not from the Netherlands, to make Amsterdam a great place to visit. So we're building applications to help people understand how people travel through the cities, or how civil servants are doing the work so it can be more efficient. And also I teach React and GraphQL with React and GraphQL Academy. So if you're looking to learn more about these technologies, then definitely look them up. So we already had a quick brief look at how frontends look nowadays. So to give you a small look again, so we need to handle stuff like state management or API composition, normalizations, caching, authentication. So these are all stuff back in the days when you just had a LAMP stack and you were writing PHP on the backend and then HTML on the front end, you didn't have to deal with state management or wrapping APIs together or things like caching. Things are way more easy. So how did this actually get this complex? So if we go back to the situation where a new feature was added to your application, we needed to update code. So a new feature is added. So something I like to add for this, I used to run an e-commerce startup for a long time. But at one time we needed to implement a wish list. And you can implement wish lists in a lot of different ways. So let's try and figure out how to implement a wish list. So again, in the ideal situation, you got like green grass and very good backenders. And if you want to implement a wish list, probably your backend is going to create a new endpoint for this, which is called something like wish list. And on the front end, you're going to make technology to actually fill this endpoint with data, and then you have some put request, or maybe some post, and get request, or deletes. So ideally, both teams will enter this new feature, and all will go well. You don't need to do anything really interesting on the front end. And probably you need some caching as well, because you want people, even when they aren't authenticated yet, to know that there's some information about them available. So these are things you can do on the front end, but probably it's best to do them on the back end and share like a session token or something. So assume you use this wish list, but you don't have an active backend team. There are ways to solve this in a browser, right? So probably you're going to use local storage or session storage to share information about the wish list. So you have to write a lot more code, but you can deal with this without having a backend. But then again, you need to add like extra difficulty and complexity to your front end, because you need to write local storage, you need to read from local storage, maybe you need to delete them once they shouldn't actually be in a front end application.
Okay.
But then suppose you work on a wish list and you have multiple teams using the same API. So maybe you're implementing a wish list on the e-commerce application for customers, but maybe someone else is building like a white label or maybe something for partners. Then all those applications will be able to use your wish list as well. It's something that might not be as well, because probably you're trying to make this wish list especially good for your application. So again, in this situation, it isn't that complex yet, because you're just getting the wish list endpoint that you actually want to use. For the other team, it can be complex, because maybe you're already creating a wish list for them that they don't want to implement later on. And then you can even think about having decoupled backends. So maybe there isn't just one backend team, maybe there are two, maybe there are three, maybe there are even more backend teams. And maybe those backend teams aren't actually inside your organization. So maybe these are external backend teams, maybe using third-party software for this. So it's going to be hard to communicate with all those different APIs, and especially to keep like normalized fields over all those APIs. So all these things, like implementing different APIs for different teams or different partners, they're going to add complexity to your front ends. So with all these changes, you can probably say that the API that you once built does no longer match your front end, because your front end is changing every day, and your UI as well. And then again, your backend probably, it's more stable. It isn't changing that often, or maybe it is being controlled by yourself. So there are situations like this when I think you would actually need a data layer in your application, because you should have one point of entry for your application that's specifically tailored for your application. So you don't have to deal with stuff that shouldn't be in there, you don't need to deal with complexity that you wouldn't need. And when I was looking at the true definition of a data layer, and you can probably read it all, it's in computer science, it's a layer of computer program to provide you simplified access to some sort of storage. And then you're probably thinking, is my API already a data layer? So yeah, probably your API is already a data layer. So if you have to quote Inception, it's like you're basically creating a data layer for your data layer, maybe on top of another data layer, because maybe you're using an ORM on your API, or maybe your API is built on top of other APIs. So it can get quite complex. Something I like to do with the data layer is keep it as simple as possible. So if you're creating a data layer, it should be specifically tailored for your application. And I'm not sure if someone that works on the backend is working with microservices or backend for frontends. Does that ring a bell for people? So basically the idea about microservices and backend for frontends is quite similar, because your backend for frontend, it will generate all the information that the frontend actually needs. And if you're not using something like this, or maybe you actually are using a backend for frontend and multiple frontends are using the same backend for frontend, it isn't really a backend for frontend anymore. So my idea about a data layer, it comes from the same principle as having backends for frontends. Because something like this would work with decoupled backends as well. And for this I like the approach for the data layer to be, you can actually see all those different APIs or endpoints or services you're using. They can be microservices to your application. And actually using the data layer as a way to get information from those services, from those APIs, and construct them in a way that you actually want to use them in your application. So basically that would be like moving a lot of logic that you have in there, like API composition, or trying to get something from state, or trying to normalize data. All those information from those APIs, you can actually get them from the API, and in the data layer you can transform them, normalize them, and use them in a way that actually your UI is using. And something I really like about this approach is you're actually getting, you're actually using the APIs and the service from your backend teams as sort of a source of truth. And on top of that, with your own front-end team or UI team, or how you like to call them, you can actually be the owner of the data that goes into your application. You can be able to name fields like you want them to name, and actually have control about everything that flows into your application, and really get all the complexity out of there that you aren't using. So I briefly told you already, but what would you handle in the data layer? So I summed up some of the things you would handle in the data layer, and for me, number one thing is API composition and data normalizations. So state management is actually something you handle in the data layer, but later on I'm going to show you using GraphQL for the data layer. With GraphQL, you actually, because your calls to the GraphQL server are way easier than calls to the REST service, you would actually get rid of a lot of state management, because it's getting easier to get data from the data layer, it's getting easier to get data whenever you need it and when you need it. And also, if you use something like React or Angular, there will be some state management in the GraphQL components or GraphQL hooks already. And something I wouldn't handle in the data layer is authentication, I've told you before. Authentication can get really messy, especially if you have authentication in your APIs and you would have authentication in the data layer as well. You would have authentication at 2 points. So I wouldn't advise doing this. I would just pass along like the JWT token or whatever kind of token you're using. Just get the token on the front end, pass it through your data layer and pass it through your APIs, and let them handle the response. If your backend developers have set up some sort of API or service that's reliable, it will return you with a status code that you can handle in your data layer. So if you're sending a token that doesn't work, you probably get an authorized error back, so you can handle this token or this request like you want to use it. So like I told you before, we're using GraphQL for this. And who isn't familiar with GraphQL yet? So some people, almost everyone's familiar with GraphQL already. That's great. So one thing I really like about GraphQL, it solves the N+1 problem. So basically the N+1 problem, if you don't know, is when you're sending 3 different API requests at once, because you need to have information about the product, maybe you also need information about product categories, maybe you need information about product ratings. If those 3 are 3 different endpoints, you probably need to send 3 requests to a server to collect all the information. And with GraphQL, you would combine all those relationships together in one single endpoint. So if you would handle the data fetching in your data layer, then you have to send only 1 request from your front end to the data layer, and then from your data layer you can handle the 3 different requests. And it depends on how you set it up, but probably your data layer will be a lot closer to your servers than your front end is. So you have some efficiency, but not complete efficiency. But those are things you can figure out later on. And one thing I mostly like, I really like the N+1 problem that's been solved by GraphQL. Something I really like is the developer experience. If you're writing a fetch request, or maybe using Axios or some other library to do the fetching for you, you also have to deal with promises. Promises can be a real help, especially if you're a junior developer, or maybe you haven't slept that well, then you probably get stuck in promise hell. I mean, when I haven't slept that well, sometimes I don't understand why my promise is still pending. But then you need to wake up, drink your coffee, then you know. Whereas GraphQL, there are components to help you with handling promises. And next to components, there are also hooks, if you're familiar with React. And even if you don't want to use any component, you can still send a regular fetch request. And instead of sending parameters, you would send a body, which would be like the parse GraphQL syntax tree. And this is where TypeScript comes in place. GraphQL introduces a type system. So if you're sending a request to a REST endpoint, you probably don't know what the fields that come back will look like. It will be an array, it will be an object, whatever will be in there, you don't really know. Because REST typically doesn't describe those, and maybe there is like a Swagger definition to find it. But I don't know whose backend developers are actually creating documentation. Like my backend developers, they usually start the documentation and then they add new features and the documentation gets lost. So something I really like about GraphQL, it has a type system. And the type system will help you know what your data will look like. And also GraphQL is all about graphs. So if you're familiar with REST endpoints, you probably think about data in like fixed structure. So an endpoint will give you a set of data. With GraphQL, you think about graphs. So you can structure how your data will look like all by yourself. And true, it depends on the backend implementation. But in general, you can structure the data yourself. So you are the owner of your data and how it will look like and how the data will flow into your application. So if we look at the situation we had before, so we would have a front-end team, and we would have a back-end team, or maybe multiple back-end teams, and they create their APIs. So they create those services. So those services, they are actually your data source. So if you look at the API that's maybe exposing your databases, it can be one API, it can be multiple APIs. Something, as we're doing with GraphQL, we're thinking in graphs. So what you'd like to do, you would like to make a graph out of those existing endpoints, out of those existing APIs, out of those existing services. So probably what you do at this point, you would look at all your REST endpoints. You actually gather all the data that you want to have from those REST endpoints. So maybe you're having a products endpoint to return you a title and a price. Those are things you only use from this endpoint. You would create a graph on top of those endpoints and defining that you want to have like a title and a price. And you can do the same for all the other endpoints. And then maybe you're using a third-party application for getting customer reviews, or maybe using a third-party API to handle your payment. So these are all things you can put graphs on top of it, because you probably will know what your request will look like and what the response will look like. So if you're handling these things like graphs, you can actually control how the data flows from these graphs into your data layer, and then later on control how this data is being getting from your data layer into your application. And so we have this situation again, and you've defined graphs for all your different endpoints, for your different services, for your different any other API you're getting in there. And if you would look at this, you would have something like schema federation. And if you're using Apollo, you've probably heard about schema stitching. And like a year ago, they introduced Apollo federation. And federation it's a variant of schema stitching. Basically, it means bringing together multiple GraphQL schemas or GraphQL graphs together to get data from all those graphs at once. And if we're looking at this situation again, so you can also think about it maybe your API team is already creating GraphQL APIs, so they would already have a schema. So with schema federation, you can either choose to create your own schema and then use it in federation, or maybe your backend team is already creating GraphQL APIs, so they can add their existing schema to your federation. So that way you would always have one schema that applies to your application. So basically it looks something like this. So you would create a schema on top of your external services, or your external services already have a schema. And this schema will be federated so you can use it in your data layer. So in your data layer, you're getting the information from the services, and you're gonna expose them so they can be used in the front end. And you will do the same for your existing APIs. And if your existing APIs are GraphQL APIs already, then probably you need to do some data transformations or normalizations. And for this, is something which I really like to use TypeScript for. So like I told you, GraphQL already introduces a type system. GraphQL is using a type system, and TypeScript can help you with dealing with types. So if you're using TypeScript in strict mode, you won't be able to use your code if your types aren't matching. So suppose you're creating your own schemas on top of these services, then probably you need to normalize the data that's coming from these services to be able to actually use them in your front end. Because somehow you need to get the right fields out of there, you need to combine endpoints together, you need to get data from external services and match them all together. So if you need to do any data transformations, really use TypeScript for this. Because you can imagine, if you're using GraphQL in your data layer, and you're using GraphQL for your existing services, and somehow the types don't match, you're going to get errors. So your code won't run, or you won't be able to fetch any data in there. And if you don't use something like TypeScript in the middle, it's going to get really frustrating, because you're getting types from some place, and maybe something starts as a string, and it ends as like an array, or maybe it's going to be a number. If something doesn't match in between, your code is going to break. especially if you're getting these normalizations in there, it's really easy to break your code. And something else I really like about if you're already using TypeScript for the normalization part and you're using GraphQL as well, it will be able to use end-to-end type safety, or almost, because probably you're not owning your database, so you can't define what types will be in there. With end-to-end type safety, it already comes in place, and this is something you would really like of a data layer, because if you don't have type safety in your data layer, you probably still end up in the front end checking if your string is actually a string. So these are things you don't want to do in your front end. And something I really like for getting end-to-end type safety in there is GraphQL code generator. And by using this, you can do two different things, or actually you can do a lot of things. Two things I really like that you're doing is creating types for your resolvers from your schema, and then again use your schema from your GraphQL service or maybe your GraphQL data layer and transform those schema with documents together into components you can actually use. So with code generator, Apollo has a code generator as well, but it only creates Apollo components. With GraphQL code generator, you can also create components for other packages like URQL, or you probably have vanilla and TypeScript components you can create as well. Still, you can also create Apollo components. So if you're doing it like this, you're probably so you're building graphs on top of your existing services and APIs. You're going to use TypeScript to normalize the data, and you're probably going to use this package to get types from your schema. And then in your data layer, you would have all of those data available, and you would also have schema available that will return information to your front end. So overall, you would basically own all the types except for what's underneath your existing APIs and services. So you're almost there for type safety. And then something we needed to handle was like authentication, but I think it's really out of scope in this place, because we'd just be passing along the token, so your APIs can handle it. But something we can handle with this is state management, just like I told you before. If you're using GraphQL, you probably have query components or query hooks, and they will make it easier for you to handle state management, because probably you don't need any state management at all. Or maybe you need to track if your pop-up is open or not. Those are things you can handle quite easily with state management solutions that are maybe already in React, or for Angular you can still find other ways to work around it. An API composition is something we can also handle in the data layer. So in your data layer, you handle API composition, so you don't need to merge reverse observables or use Redux sagas. And then, of course, data normalization is something we also handled in here. And basically, the only thing we didn't really cover was caching. And so caching is always tricky. That's why I probably tried to avoid this topic for some time. But there are multiple ways to cache a data layer. So you can actually cache the results from your APIs and services inside the data layer. But then probably you would have to run your data layer somewhere where there can be caching done. And there are multiple ways to think about it like this. How would you handle caching with authentication tokens? So I think caching can be maybe too complex for your data layer at first. But something that you can easily handle caching in is actually when you're using GraphQL, something like Apollo or URQL. It can be easier to cache those queries on your front end. So caching would be the only thing from this list that I would handle on my actual front end. But then probably this is the first question that someone would ask me: do I really need a data layer? I don't think you don't really need a data layer application if you have a backend team that can help you constructing endpoints, or maybe already constructing a GraphQL API that fits the needs of your UI. But yeah, that's like an ideal world. So most backend teams I work with, they either can't work on the same level as UI developers are working on, or they don't have the resources to create actual endpoints that you want to use. So typically you don't really need a data layer unless you're using a really big application that isn't having an active backend development team, or maybe that's been built on top of existing services already. Something I do really like from a data layer, like we saw, it makes for a great migration path. So if you have a data layer with schemas, and then you're using existing APIs and services, then also you've created a schema for those services, and later on your backend team can easily replace those APIs with an actual GraphQL API. So if your team is eager to start working with GraphQL, and probably most frontenders are willing to work with GraphQL, and most of the backenders aren't convinced right yet, you can start to build this data layer and have some sort of migration path in there already. So if you would want to learn more about this, you can ask me on Twitter or later on in here, and I think we should have time for questions right now as well.